This lesson has a lot of different applied problems that have to do with polynomial long division and the remainder theorem. When we think about Regents exams, 90% of the questions are things you'd expect, and you really have to know your math from the whole year to get them right. And some things will just be things that you haven't seen, and you have to take what you know and apply it. Now, these are some of the situations we've seen or some that we might expect on a Regents exam. We'll read through each one. I suggest trying to think about them on your own first, but ultimately you're going to say, okay, here's what I know from the last two lessons, and this is how it could help me solve this question. So the first one says the graph of f of x is shown below. What is the remainder when f of x is divided by x minus 4? So this is a remainder theorem question. And we know to find the remainder when f of x is divided by x minus 4, we would evaluate f of 4. So on our graph, basically we just go over to 4 and we try to find the y value. So I'm going to say that's about 100. If this was on a test, it would be, a nice, neat point for you to find. So the remainder when f of x is divided by x minus 4 is 100. Another way of looking at it is that the function is 100 off from x minus 4 being a factor. The next one is similar, so let's look at it. The graph of g of x is shown below. For how many values of a is the remainder when g of x is divided by x minus a equal to negative 3? So they're telling me the remainder when g of x is divided by x minus a is equal to 3. So we know to find that remainder, we would evaluate the function at positive a if we're dividing by, or our factor is x minus a that we're dividing by, and they're telling me what the remainder is. So they're telling me that wherever these spots are, the y value equals negative 3. That's the remainder, right? So looking here, that's a y value. So I'm going to go on my graph across, and it just asks me how many times. So there are 4 different spots on my graph, 1, 2, 3, 4, where this would be true. Basically, there's 4 values of a where the remainder, when we divided by x minus a, would be negative 3. So that's 4 times. And then they want me to estimate those values of a. Now this is another one where we're really estimating. So I don't know, this one looks like it's a little to the left of negative 4. The first one, so let's say it's like negative 4.2. This one looks like it's pretty close to negative 1. Okay, maybe it's a little bit off. Maybe I'm going to say negative 1.1. This one looks like it might be right on 0. And then this one over here, it's 3 right up here, so I'm going to say it's a little past 3, maybe 3.2 for the last one. Those are the 4 x values where the remainder is negative 3, 4 values of a. Now, it's tricky because do we make them negative? Do we keep them positive? Because this already has the negative sign, we're keeping the values of a. We're not like negating them or anything like that. So moving down the page, those two are really about understanding remainder theorem in the context of graphs. The next one has a little bit more to do with algebra. So it says, for the cubic function f of x, and this is a typo, so let me fix it. This should say f of negative 3 equals 0. Find the roots of the function algebraically. Note, 2 of the roots will be irrational, so you need to choose an appropriate method to solve that part of the equation. So basically, let's just ignore that for now. It's going to come up later, that part about the irrational roots. If f of negative 3 equals 0, the factor theorem, part of the remainder theorem, tells me that means x plus 3, opposite sign, is a factor, right? It's right equal to 0, it's not off, so that's going to be a factor. So to start to factor f of x, so we can start to find the roots, I am going to divide f of x by x plus 3. So quickly through, and just go back to that polynomial long division lesson if you want a refresher on this, or if you didn't get that part, because this is going to be fast here. So we multiplied x plus 3 times x squared, then we changed the signs. So we get 4x squared, this cancels, we bring down the 13x, x goes into 4x squared 4x times. and that's going to be 4x squared plus 12x. So when I subtract and change the signs, when we bring this down, I'm just going to move the page up a little bit. So I have room. I do get canceling and then an x, and we bring down the next number, plus 3. So we can already see that x plus 3 is going to go into x plus 3 one time. Multiply it out and subtract, and we get 0. As expected, because f of negative 3 equals 0, we expected x plus 3 to be a factor. So basically I'm trying to get this into a factored form because we're trying to find the roots algebraically. So basically I probably should have written this first, but if we're trying to find the roots, we're setting the function equal to 0. So I was initially should have written down, I'm setting this function equal to 0, which is why I want to get it factored so I can start to solve it. The first part, and this should not be a shocker, is that x equals negative 3, but we already knew that, right? We knew f of negative 3 equaled 0. The other problem is we need to get the other two roots from that quadratic factor. Now, as promised in the directions, we need to choose an appropriate method. I can try to factor this further, but there are no numbers that add up to 4 and multiply to 1. So that means I need to use the quadratic formula for this part. So it's been a little while, but negative b, so negative 4, plus or minus the square root of b squared, 4 squared minus 4 times 1, all over 2 times 1. Simplifying, we get negative 4 plus or minus the square root of 12 over 2. We can see we don't have a perfect square. That's where our irrational roots are coming from. So I have negative 4 plus or minus radical 4 radical 3 over 2 equals negative 4 plus or minus 2 radical 3 over 2. We do have simplification here. We have a common factor between our negative 4, our positive, or 2, and our 2. So this is going to become a negative 2, a 1, and a 1. So over here on the side, I'm going to write my roots. I'm going to use the squiggle brackets. So I have a negative 3, a negative 2 minus radical 3, and a negative 2 plus radical 3. Technically speaking, my negative 2 minus radical 3 is smaller than my negative 3, so maybe I would want to write these in the opposite order. But yeah, as I said, it's not a big deal. We don't have to write those in order. Just to kind of wrap this one up, remember if we have a cubic polynomial, the fundamental theorem of algebra says we should have 3 roots. We got 3 roots. We started out with factoring using polynomial long division, and then once we had it broken down into a linear factor, linears are always easy. Quadratics are trickier, but once we get it down to quadratic factors, even if we can't factor or it's not an incomplete quadratic, we can always use the quadratic formula to find the remaining roots.